Most people think that sleeping 5 hours or 7 hours is almost the same. After all, it is only a difference of 2 hours. In a busy modern world, both numbers might sound normal. Many people say they sleep around 5 or 6 hours during the week and try to recover later. But, from a neuroscience perspective, 5 hours and 7 hours of sleep create very different conditions inside the brain. Those 2 missing hours can completely change how the brain repairs itself, processes memory, and regulates emotions. To understand why, we first need to look at how sleep is organized. Sleep does not happen as one continuous state. Instead, the brain moves through repeating sleep cycles, each lasting about 90 minutes. During each cycle, the brain passes through several stages: light sleep, deep sleep, and REM sleep. Deep sleep is especially important for physical recovery and brain maintenance. During this stage, slow brainwaves dominate and the brain begins clearing metabolic waste that accumulated during the day. REM sleep, on the other hand, plays a key role in emotional processing, creativity, and memory integration. In a typical 8-hour night, the brain completes about 5 full sleep cycles. When sleep is reduced to 7 hours, the brain may still complete around 4 cycles. This means most of the essential stages still occur, although the final REM-heavy cycle may be shortened. But when sleep is reduced to 5 hours, the situation changes dramatically. Instead of 4 or 5 cycles, the brain may complete only 3. This means large portions of REM sleep and deep restorative stages are simply missing, and this is where the difference between 5 and 7 hours becomes much more significant than it seems. In sleep laboratory studies, participants restricted to 5 hours of sleep show noticeable changes in attention and reaction time. After just a few nights, they become slower at detecting visual signals, more prone to making small mistakes, and less capable of maintaining sustained focus. 7 hours of sleep, by comparison, produces much smaller cognitive changes. People sleeping 7 hours may experience mild fatigue, but their overall performance remains relatively stable in many tasks. In other words, 5 hours pushes the brain closer to true sleep deprivation, while 7 hours usually remains within the lower boundary of normal sleep. Another major difference appears in emotional regulation. The brain's emotional center, known as the amygdala, becomes more reactive when sleep is severely reduced. Research has shown that after very short sleep nights, the amygdala responds more strongly to negative emotional stimuli. At the same time, the connection between the amygdala and the prefrontal cortex becomes weaker. This means emotional reactions become stronger, while rational control becomes weaker. People sleeping only 5 hours often report increased irritability, lower frustration tolerance, and stronger emotional responses to everyday stress. 7 hours of sleep usually allows enough REM cycles to keep this emotional balance more stable. Memory is another system strongly affected by sleep duration. During sleep, the hippocampus and neocortex work together to reorganize memories from the day. Important information is strengthened, while less important details fade away. When sleep is shortened to 5 hours, this memory consolidation process becomes less efficient. Students and workers who consistently sleep 5 hours often show slower learning and weaker recall compared to those sleeping 7 or 8 hours. 7 hours still allows the brain enough time to perform much of this memory processing. Although the final stages may still be slightly reduced, the long-term health effects also differ between these 2 sleep durations. Chronic sleep patterns have been associated with increased risk of metabolic problems, cardiovascular stress, and reduced immune function. 7 hours of sleep, while not always optimal for everyone, tends to fall within the healthier range for many adults. Another reason 5 hours of sleep is so problematic is something researchers call sleep pressure. Throughout the day, the brain accumulates molecules, such as adenosine, that signal the need for sleep. When sleep is too short, these molecules are not fully cleared. The next day begins with residual sleep pressure still present in the brain. Over time, this builds into what scientists call sleep debt. With 5 hours of sleep, this debt grows rapidly. With 7 hours of sleep, the brain is often able to keep this pressure relatively balanced, especially if sleep quality is good. This is why someone sleeping 7 hours may still function reasonably well for long periods, while someone sleeping 5 hours often begins experiencing noticeable fatigue after only a few days. Another interesting difference between 5 and 7 hours of sleep involves reaction speed and accident risk. In controlled experiments, participants sleeping 5 hours show reaction times similar to mild alcohol impairment after several nights. Their brains simply cannot process sensory information as quickly. 7 hours of sleep produces far smaller reaction delays. This difference becomes especially important in activities such as driving, operating machinery, or performing complex tasks that require sustained attention. But perhaps the most surprising finding from sleep research is that people often cannot accurately judge their own level of impairment. Participants restricted to 5 hours frequently report that they feel mostly okay, even while their cognitive test results continue to decline. The brain adapts to sleep loss in a way that hides the true level of impairment. 7 hours of sleep usually prevents this extreme mismatch between perception and performance. This is why sleep researchers often emphasize that small differences in sleep duration can have large effects over time. 5 hours of sleep may allow someone to stay awake and function, but it pushes the brain into a state of chronic recovery deficit. 7 hours of sleep, while not always perfect, usually allows the brain to maintain a far more stable balance between activity and recovery. So when people ask whether 5 hours or 7 hours of sleep is enough, the answer from neuroscience is surprisingly clear. Those 2 hours can mean the difference between a brain that is struggling to recover and a brain that is still able to maintain most of its essential nightly processes. And in the long run, that difference can shape how clearly we think, how stable our emotions remain, and how effectively our brain supports us throughout the day. Another key difference between 5 and 7 hours of sleep appears in how the brain regulates hormones that control energy and appetite. Sleep directly influences hormones such as leptin and ghrelin, which help regulate hunger and feelings of fullness. When sleep becomes severely restricted, as it often does with 5-hour nights, the balance between these hormones begins to shift. Ghrelin, the hormone that stimulates hunger, tends to increase. At the same time, leptin, which signals satiety, tends to decrease. As a result, people who regularly sleep very short nights often experience stronger cravings for high-calorie foods. This effect is not simply psychological. It reflects real biological changes occurring in the brain and body when sleep recovery is incomplete. 7 hours of sleep usually provides enough recovery to keep these hormonal systems more stable. While it may still fall slightly below the ideal amount for some individuals, the body is generally better able to maintain metabolic balance. Another system strongly affected by sleep duration is the immune system. During deep sleep, the body produces signaling molecules known as cytokines that help regulate immune responses. These molecules play an important role in fighting infections and maintaining overall health. When sleep is shortened dramatically, especially to 5 hours or less, the production of certain protective immune signals decreases over time. This can leave the body more vulnerable to illness and slower to recover from infections. 7 hours of sleep still allows the body to enter deep sleep stages long enough to maintain many of these immune processes. The difference may not always be obvious in daily life, but over months and years, consistent sleep patterns influence how effectively the body protects itself. Sleep also affects the brain's ability to manage stress. When sleep is too short, levels of cortisol, the primary stress hormone, can remain elevated for longer periods during the day. Higher cortisol levels can increase feelings of anxiety, tension, and mental fatigue. People sleeping only 5 hours often experience stronger physiological stress responses, even to minor challenges. 7 hours of sleep usually allows cortisol rhythms to stabilize more effectively overnight, helping the brain reset its stress regulation systems. Another fascinating discovery from sleep research involves creativity and problem solving. REM sleep, which becomes longer in the later hours of sleep, plays a crucial role in connecting distant ideas and integrating complex information. When sleep is reduced to 5 hours, the brain may miss much of this late REM activity. This means the brain has fewer opportunities to reorganize knowledge and create new associations between ideas. 7 hours of sleep, although still slightly shorter than ideal for some individuals, preserves much more of these REM-driven cognitive processes. This may explain why people who consistently sleep slightly longer often report clearer thinking, improved creativity, and better problem-solving ability. Taken together, these differences reveal something important about sleep. The brain is not simply asking for time to rest.